Hi guys, welcome back. This is Creative Crackers 7 and I'm Shiva. We are making projects and prototypes. In this video, we are going to make a robotic arm. No, that's a topic for previous video. In this video, we are going to make a weight machine with Arduino. Without wasting further time, let's get into the video. And don't forget to subscribe to our channel. Only then you will be notified whenever we are uploading a new video. Give your feedback by liking this video and commenting how it is. Or if you want any videos to be uploaded, please comment it down. Without wasting further time, let's get into the video and see how we can build this one.
Let's see what are the components required for this project, and then we can jump into the building part. First, we need a load cell. The weight of the load cell is 1 kg, and this is the amplifier board you can get along with it. Next, we need a Arduino. You know probably, but in this project I am going to use Arduino Pro Mini. Next, we need a OLED display for displaying the values, and then some plastic containers for fixing all the components together. We need 2 parallel holes in the container for fixing the load cell. The load cell already have 2 parallel holes on both the sides, which means our work is half finished. Then we need 2 bushes for giving height to the load cell, because load cell cannot be placed in the ground level. We will get to know at the end of the video why it should not be at the ground level. Place a bush and then place the load cell with the help of screws tight up. The same for the top also. Once it's completed, it's time to move on to the circuit connection. Make sure the angle is correct. It should not be one side up and one side down. This is the circuit for our load cell. This is the Arduino Pro Mini board which I am going to use in this project. But in the circuit diagram I have shown Arduino Uno. No mistake, you can use any of them. All the circuits are same and no need to change anything in the code. Keeping the circuit diagram as base, I have designed this PCB because we can easily plug up the components and insert it. Just insert the components one by one. Now Arduino Pro Mini. Now our work is to program. Before that I have build a separate PCB for display. You can connect this both by just inserting. While fixing in the container, we can use jumper wires for fixing both together. This is the FDTA programmer for updating our code or burning the bootloader. Okay, insert it and grab your PC or laptop. Open Arduino Sketch. I have given link in the description for both the programs. There are 2 files, calibration code and load cell. First, upload the calibration file. Check for board and port. Yes, both are correct. Upload the sketch. Once it's uploaded, open serial monitor. Keep the baud rate as 15,600. Once it's started, place the load cell without any weight and enter T. And then place a weight, known weight. In this I am going to use the soap. The soap is 250 grams. Okay, we know the weight I have placed, and the serial monitor I have entered 250. Okay, we got the calibration value. Just copy the calibration value and go to the another sketch named as load. In this load, here you can see 4,5. These are the SCK and DT pins. In the calibration also you can see SCK and D are connected to 4 and 5. In case you are changing the circuit, you have to change the numbers here also according to your digital pins. This star is nothing but the push button connected pin. Okay, scroll down and you can see set cal factor. Here paste your calibration value. Each load cell has its own calibration value, so don't copy my calibration value. Find your own calibration value according to a load cell. Let's see how the load cell works. This is the common resistor which we are using every day, and its resistance value is fixed. Then here comes a stress gauge, which is nothing but its resistance change according to the force applied. This this type of resistors are fixed in the load cell in the top and bottom. At the center you can see the white color coated is nothing but the resistor. Now whenever a load or force is applied on either end of the load cell, the resistance will changes. The change resistance is less, so we are going to use an amplifier board. Then the next question is, what is calibration value? For that we can see an example. X is proportional to y, which means x increases, y also increases. When x decreases, y also decreases. In the same case, we can derive some mathematical equation. Resistance is directly proportional to force applied, which changes to resistance equal to constant into force applied. The constant is nothing but calibration value, which determines the rate of change. Okay, now let's power up. The display is working. We can fix it. If you have any doubts, please comment it down. We are ready to help you at any time. Okay, let's test how it's working. If you like this video, give it a like, comment, and don't forget to subscribe to our channel. See you in another video.
I hope you enjoyed this video. If you have any doubts, please comment it down. We are always ready to help you. And don't forget to subscribe to our channel. This is Creative Crash 7 and I'm Shiva signing off.